And this is the world of the pollinators. And we're going to be talking about this tiny little world that surrounds us, and the parts of the flowers, because this is where the pollination happens. So here we see petals, stamens, pollen, the stigma. And I'm going to talk about the parts of the flowers because we can't really talk about pollination without really understanding the parts of flowers. And by the way, this plant, you can immediately tell it's probably an apple blossom, but it is certainly a flower of the Rosaceae family, because it has 5 petals that are quite often white, and lots of stamens. And so just at a glance, you can say this is a Rosaceae. And it's worth mentioning plant families because there are some pollinators that will go to specific families, and we're going to talk about that a little bit. This is our garden at High Plains Environmental Center, and in other classes I have talked about the water usage in this garden. Next month we're going to be talking. We're going to have a big water conservation focus here at High Plains Environmental Center, and our class will be about how low can you go in watering native plants. But today I just want to talk about by the way, this is a garden that is never watered, but I want to talk about what happens when we really look closely at the plants. And this is a photo of our garden in October. And if you look at this little patch of blue in the corner, when we zoom into that a little closer, this is the Bigelow's tansy aster in all of this blue. And when we get really close, you can see there's these sulfur butterflies in there. And actually, this is one plant that is will attract a large number of pollinators of many different kinds. But this is a tiny little world that we really have to look closely and peer into this hidden world to learn more about what's going on in our garden. I want to point out something on this little butterfly here. Is this it's like a straw that they're sipping nectar out of the flower, and this is called a proboscis. So when you really look closely, you can actually see that they're sipping the nectar out of the flowers with this little straw, the proboscis. And there are these intimate relationships between all these different pollinators and flowers, and they are extremely intricate. We're going to talk this morning about how these co-evolved to benefit one another. A species of flowers and a species of insects have co-evolved in a way that is often mutually beneficial. And we don't really know the complexity of all of these relationships. We're beginning to learn through study what genus of insect is drawn to what genus of flowers. But the complexity of these relationships, we have really just tapped the surface of the intricacy of all of this. But I thought this was a pretty and an exciting photograph, and it begins to pull us into this tiny world of the plant pollinator ecosystem. And much of the information in this presentation today comes from Paul Opler, who very recently died. We were really sad to hear about that here at High Plains Environmental Center, because Paul was a great friend of the Environmental Center, very frequent visitor, always out there with his floppy sun hat and the big white net, swooping it over the tops of different kinds of flowers. And over the last 2 years, he did a study here at High Plains Environmental Center and elsewhere in northern Colorado, where he was counting the bees that come to specific flowers. So I've given a lot of talks over many, many years of that saying that native plants equal habitat. And if you plant native plants, if you build it, they will come. Basically plant native plants and you will begin to see a lot of diversity of pollinators. But we really didn't have the specific information, like what species was going to what particular flower, or what flowers attracted the most pollinators and so on. So Paul counted all these bees and shared it with folks at CU in Boulder. And he said that not only are the tiny differences between bees really, really hard to identify. I mean, they're easy to identify to a genus perhaps, but to species, very, very difficult to get the specifics on that. And then often the female and male are very different looking. So it's almost like we have, they're almost like a completely different, look like a completely different species. So over the last 2 years, over 100 species of bees were identified in this garden at High Plains Environmental Center. And it's just a really cool affirmation that our belief that if you build it, they will come, it is true. And we have hard data as to exactly how many bees and what kind of bees we have attracted here. So we're going to begin by talking about how plants are pollinated. And 60 to 80% of plants require animal pollinators, and the remaining plants rely on wind for pollination. And I want to just pause on this slide for a moment and look closely at this bee, and you can just see it's covered with pollen. This whole pollination game is a big mess, and it's interesting and worthwhile to point out that insect pollinators are not intentionally pollinating, but the pollination is happening as they're doing their work of foraging. They go from flower to flower, and they just get covered with this pollen, and it moves from plant to plant. I'm going to talk a little bit about the strategies for wind pollinated plants versus the animal pollinated plants. Wind pollinated plants are called anemophilous. And these plants have small petals. They're often brown or dull green. They don't need to attract insects. So you're not going to see big, colorful flowers on these types of plants. And if you think about, these plants are often monocots. Plants are divided into monocots and dicots. And the monocots mean they have one seed leaf as they emerge from a seed, and dicots have two. And the monocots include things like a pine tree and various conifers and grasses. And those are the kinds of plants that we're talking about that are largely wind pollinated. They don't have pretty flowers. They don't have scents that will attract insects. They don't have nectar because they don't have any of the strategies that have evolved to attract insects. The pollen is produced in great quantities because it does not, because most of it doesn't reach another flower. So you don't have the animal going specifically from flower to flower, which is kind of a direct contact. Just like clouds of pollen will get into the air and go from plant to plant. And if you live near pine trees, you know exactly what I mean. On a morning in June, you'll go outside and your car will just be covered with yellow dust. And so that's the pollen that is just blowing off of the tree. I've seen it when I was at the Shambhala Mountain Center. I would often see in June on a breezy day, you would just see a big puff of yellow pollen. I mean, it's so abundant, you can actually see a cloud of it. And obviously that's a lot of people have allergies to these types of plants because there's so much of the pollen put into the air. The pollen is very light and smooth, so it can be blown by the wind. And if you look at the pollen from a lot of the flowering plants, looks spiky, like one of the World War II sea mines, like really spiky, and that is so that it will stick to things. And the strategy here is that this pollen doesn't stick to things, and mostly not to each other. So the pollen doesn't clump up, but it can be scattered. And so these are strategies for wind pollination. Before I go on to the next part, I want to just talk about the parts of the flower so that the next slide will make a lot more sense. And the main things here are, again, brightly colored petals are a key that this plant is pollinated by insects or possibly birds. But that bright color and large petals and so on is to attract the animal pollinator. This part here is the stigma, and it's sticky to the touch. A great flower to look at, because all of these parts are so large and visible, is a lily. You look at a large lily, and if you touch the tip of the stigma in the center there, it's actually sticky to the touch, because that's the receptacle that pollen will stick to. And the idea is that the pollinator will get covered in the pollen, and they'll brush against this, and some of that pollen will stick, and that begins the fertilization process. There's this tube, and at the bottom is the ovary, and that is where the seeds will develop. And so that is the female parts of the flower. Some flowers are bisexual. They have the female parts and the male parts, and some don't. There are some that are just like the male flowers, and some are female. This is a bisexual flower where it's showing all of the parts. That's also in botanical terms called perfect. So if a flower is perfect, it means it has all of these reproductive organs in one. These are the stamens, and this is made of the anther, which is the organ that is actually bearing the pollen, and the filament. So the filament is just something that holds the anther up, and this is where the pollen is created. And so again, the pollinator will touch the anther, get pollen all over itself, fly to another flower, and will brush against the stigma and begin the fertilization process. So the insect pollinated plants are called Anthophilous, and the vertebrate pollinated is called Zoophilous. And so a good example in our area would be hummingbirds. Hummingbirds do pollination in our area, and in some parts, but I think more in like tropical zones, there are some fruit-eating bats that will do pollination as well. But again, the strategies that these plants have developed is they have large, brightly colored, pretty flowers that will attract the pollinator. They're often sweet scented. I mean, these are the things that we like about flowers, but the fact is, like, it's not for us. We may like flowers for their pretty colors and their nice fragrance, but that's for the benefit of insects. It's not evolved to attract our attention. And then they usually contain some kind of nectar, and that is what the insect pollinator is looking for, is a drink of this nectar. That's their food. And then also pollen is food for some bees collect pollen and for food. And so that's why the insects are going to the flowers. It has a moderate quantity of pollen. There's less wastage than with wind pollination. And some of these slides a little bit further on, we're going to talk about a further layer of evolutionary strategies that will get the pollinator to go to other flowers of the same type. Because if the pollinator is picking up pollen and going to flowers of a completely different species, it's not going to pollinate that flower, and it doesn't benefit the plant that has given up that pollen. And since the pollen is of a limited quantity, it's ideal that I have to avoid anthropomorphizing, because I often say the flower wants it. Obviously, the flower doesn't want anything. These evolutionary strategies happened because they worked, and so because they worked, they happened again. And it's not that the flower wanted to do this, but its seeds were created because it had these successful strategies. The pollen is often sticky or spiky, and so like the bee that we just saw, it'll stick to the pollinator and carry it to another place. The anthers are firm and inside the flower to brush against the insect. The stigma inside the flower, so the insect brushes against it, and the stigma has a sticky coating. Like I was saying, if you touch it, it's actually sticky, and the pollen sticks to it. Again, here is this flower is Monarda or bee balm, and this is a fritillary butterfly that you can see the proboscis there very prominently that's sticking into the flower. And this is what I was just referring to. This plant or this pollinator has this proboscis, and some bees have different tongue lengths. And so there's some nectar that some species of bees can reach and some that other species cannot reach. And so they tend to co-evolve with the flowers that they're attracted to. And that benefits the pollinator perhaps because it cuts down on competition. Like they're foraging on these particular kinds of flowers, and therefore they're successful. They find the nectar that they're looking for. And the flower is successful because it's not wasting pollen going to completely different species of flowers. And so these are the insect and pollinator relationships that become so specific. So these are some of the plant and pollinator strategies. The term oligolectic is like oligarchy. It means that an insect pollinator or a certain species will only go to a certain species or genus of flowers. So again, that's the exclusivity that I was just talking about. It keeps the pollen from being wasted. It helps to ensure the success of pollination by going to flowers of the same species, and it can benefit the pollinator because they have like the key to unlock the door that another pollinator might not. Therefore, kind of reserves that species for only those who can access it. And so this is how the plants and pollinators have co-evolved to really fit with one another. There's a diversity of ways that the bees carry the pollen. And one of I didn't point it out, but a few slides back, there was a bee that had on its leg just like a pack of pollen that just stuck to it. There are different ways that the bees can collect and carry the pollen. And there's this buzz pollinated characteristic. And I actually saw a video of this. I wish I had it to show, but it was a bumblebee inside a penstemon flower. And you could see that the vibration of the bee buzzing actually caused the flower to release a burst of pollen, which that's a very successful strategy because the pollen is actually released when the pollinator is there. So the pollinator is just like blasted with this pollen. And bumblebees and penstemon flowers are one example of where this happens. And then this idea of the tongue lengths and the various lengths of flower tubes co-evolve to fit one another. So these are all ways that there's this very specific connection between the pollinator and the plant that's being pollinated. I like to ask kids when they come to the High Plains Environmental Center, how many species of bees do you think there are in Colorado? There's 936 known species of bees in Colorado. And you know, we talk a lot about honeybees and save the bees and so on. Well, obviously, honeybees are very important. It's been estimated that 1 out of every 3 bites of food that we take is the result of pollination by bees or other pollinators. Why it's only 1 out of 3 is because the anemophilous plants like wheat and rice and things that human beings consume huge amounts of are not pollinated by insects. There are 23 species of bumblebees in Colorado, and I believe all bumblebees that we see in North America are native bees. 85% are solitary bees, and so we have a tendency to think of like bees are in a hive, and that's not really true. You do see bumblebees coming out of the ground in large numbers at certain times of the year, but they don't live there. They are where a queen bee has laid eggs and they're hatching and they're leaving the hive. They don't live there, they won't come back. There's the osmia or mason bees that use mud to seal up tubes where they lay eggs, and the leafcutter bees will roll up leaves and stuff them into tubes. And those are the kind of bees that when we see the bee houses that are for sale, those are the kinds of bees that are supported by those bee houses. There's also a large number of fly pollinators, and often when we look at what we think is a bee, it's actually a fly, and a large number of flies do the work of pollination. This bee right here is a queen bee. It comes out in May, and this is Palmer's penstemon palmeri. They're right out in front of our building, and usually like the last week of May, this starts blooming, and the queen bees are the first things to emerge from the ground. Only the queens live over the winter. The other bees die, and she will go to, this is one of the first flowers that blooms, and they are quite large. This bee is about the size of your thumb, and they will lay eggs, and other bees that we see later in summer come from them. This notion of coevolution, there's another aspect of this, and I'll just read the slide. Virtually every plant species protects its leaves with a species-specific mixture of chemicals. With a few exceptions, only insect species that have shared a long evolutionary history with a particular plant lineage have developed the physiological adaptations required to digest the chemical in their host's leaves. So the classic example of this is the monarch butterfly. Here's a monarch on a milkweed. This is the swamp milkweed. And the monarch migration follows the blooming of milkweed plants. Monarchs will feed on other plants, but they are largely drawn to the milkweeds of various species. What's more important is that the monarch will lay her eggs on the milkweed plant, and that the caterpillars will eat the milkweed plant. The milkweed plant is toxic, and most insects will not eat it. It's so toxic, in fact, that the monarch caterpillar is toxic to birds, or it tastes extremely bad. And so much so that some other caterpillars have evolved to look like a monarch caterpillar, because they know, like, after a bird has tasted, well, they don't know. I've done it again, the anthropomorphizing, but they were successful because they look like monarch caterpillars. And if a bird tastes a monarch caterpillar, they're not likely to go after another one that looks like that again. And so the plant that the monarch lays the eggs on benefits the monarch species, because that's how the young survive until they become a butterfly. But the monarch also pollinates the milkweed. So we have this symbiotic relationship where the pollination of the plant is dependent on the monarch butterfly, but the development of the caterpillars into butterflies is dependent on the plant. And so they help one another. And Doug Tallamy, who wrote the book Bringing Nature Home and Nature's Best Hope, he's an entomologist from I think Penn State, and he says if you look at your garden plants and you don't see something's chewing the leaves, then it's not really working. Or you could turn that around the other way. If you see some bite marks in your leaves in your garden, then you know the garden is working. You know the garden has an ecological function, and that's a good thing. We don't have to run to the store and douse everything in pesticide because of a few leaves getting chewed. Because, you know, aside from Japanese beetles, which we don't particularly want, caterpillars chewing leaves is an important ecological function. We're going to talk a little bit more about why. Insects take the energy that plants generate from sunlight and send it up the food chain. Insects provide the basics of diet for 96% of all terrestrial birds, particularly during the breeding season. So if you look at baby birds, you will see that they are not made of birdseed, they're made of caterpillars. I mean, that is what they need to develop. And if we are taking insects out of the ecosystem, then that has an enormous impact on birds, because we're taking away what birds depend on. Decline in biodiversity. Obviously, biodiversity is a global issue, and there is an enormous amount of species that are threatened by climate change and habitat loss and other issues across the entire globe. And a lot of scientists and concerned citizens are focused on how we can change that. The surveys by the Audubon Society revealed that bird populations in Colorado have declined 60% within the last 40 years as a result of suburban sprawl. Honeybees and other pollinating insects have experienced a similar decline within the same time frame. So again, honeybees are not native bees, but they are important globally for food production, and our species is directly dependent on them. The pollination that is done by other species of bees is important, because the whole idea of biodiversity is if you have a lot, there's more resiliency in the ecosystem. If you have one species of pollinator and you lose that one species of pollinator, you're in really big trouble. But if you have other species, even if one is declining or its population is fluctuating, there are other pollinator species that are doing the work. But why pollinators are important, obviously, is because we would rather quickly not have plants, whether they're wildflowers or the foods we depend on, without the insect pollinators. And we're giving that all up for what? You know, we're losing the beauty and the intricacy and the resiliency of nature and the ecosystem to create this sterile and sort of monolithic world. And it doesn't have to be that way. So the rest of this whole presentation is to talk about how we can be more creative and more innovative about how we design and build our world. I'm not saying we don't have, you know, we can't have homes or we don't necessarily have to have the lifestyle we have, but with a few adaptations, we could actually invite back all of this biodiversity into the world that we design and build. Again, these are some statistics from Doug Tallamy. 98% of the lower 48 states has been altered for human use. 43,480 square miles are covered by pavement. So obviously there's no biodiversity there. It's just a dead zone. And then we have 62,500 square miles of suburban lawns. I wouldn't go so far as to say there's no biodiversity on a lawn, because we've all seen robins pulling worms out of the ground, and there's things going on. Although the more chemicals we're dousing that lawn with is probably not as much biodiversity going on below the soil line as there could be. But it isn't like there's no biodiversity. But after World War II, this concept came that you just have to have a pure grass lawn, no dandelions, no flowers of any kind. And before that, white clover was very commonly part of a lawn. Having white clover in a lawn makes a lot of sense because the clover fixes nitrogen, helps to share that nitrogen with its neighbor, the turf grass, and it provides something that pollinators can access. So we have created this monoculture, and it's actually quite large. Again, Doug Tallamy says that if you took all of this turf grass and put it together, it's the equivalent size of our 10 largest national parks. And that is an enormous amount of area. We use more pesticide and herbicide on that particular, and fertilizer per square foot on that crop than any other single crop, and 800 million gallons of gasoline to support this. So a lot of effort and a lot of money has gone into creating something that is very questionably low value to aesthetically or in terms of supporting biodiversity and ecological function. So how can we help pollinators? That's really the point of this presentation. First of all, grow native plants. And there's some debate about what is native, what is not native. Is it native to Colorado? I tend to think that Colorado is an arbitrary political designation. And if we were going to grow plants of our biome or our ecological zone, we would be looking at the high plains. Well, I'm assuming that most of the people who are in this class this morning live on the Front Range. The majority of people in Colorado live on the Front Range, and we're really right at the very western edge of the high plains. If we were looking at Aspen and other high altitude communities, they might have a lot more to do with Montana and Wyoming and than the Front Range, just because they have different plants, they have different climate, and everything's different. We have more in common with Nebraska and western South Dakota, eastern Wyoming, eastern New Mexico, the Texas Panhandle, and western Oklahoma than we do have in common with places like Vail and Aspen, because all those places are the high plains. But growing plants that come from within your ecological zone is what I would consider native. And why that matters is because those are the plants that co-evolved with our native pollinators. And some plants like the honeybee will love Russian sage. If you look at Russian sage in summertime, it is covered with honeybees. Well, that's a European insect on a European plant. So that makes complete sense. But if we want to support the diversity of our native insects, we need to have the native plants that they co-evolved with. So things that I see in this picture is the Mirabilis multiflora, desert 4 o'clock, the butterfly milkweed, Asclepias tuberosa, and then behind is the Artemisia frigida, fringe sage. Designing a landscape with ecological function. So it's interesting that good landscape design really aligns with the notion of ecological function. And here's an example. Provides sunny open areas. Most bees forage mainly in the sunshine, and honeybees and bumblebees are exceptions to that. Create windbreaks to the north and west. I mean, that's a permaculture idea. And anybody who lives in a harsh northern climate knows this. You know, you want to plant your plants on the south side of a wall. They're going to reemerge from dormancy earlier. That's just logical. Create layers, including middle, tall, and low woody plants. And I have another slide further on where I talk about how, if you look at woody plants and how they grow in the wild in Colorado, you will notice that they grow in colonies, and mostly with several different species together, often in the shade of a cottonwood tree. And so not only is that make good sense in that the plants all support each other in that kind of arrangement, it creates a situation that supports a lot of pollinators and provides a lot of different opportunities within that planting arrangement. And we can replicate the same thing by the way we plant and design our gardens. And then leaving dead tree branches when possible. I've seen in my neighborhood, sometimes instead of cutting a tree right to the ground, people will just cut it at like 15 feet high or something like that. And eventually you'll see woodpeckers making homes, or other birds perhaps, that you might see hawks using it as a perch to rest or to hunt from. That can have some ecological function. And being a neatnik in your garden really isn't beneficial for preserving biodiversity, because the twigs and leaves and the forest floor kind of thing that will develop after we've planted plants in our garden is actually important. So having landscapers come in and pick all that stuff up and put wood mulch is really not necessarily going to help with maintaining the biodiversity in our landscape. Avoid using pesticides as much as possible, specifically insecticides, and the neonicotinoid pesticides or insecticides are extremely bad. I have a fairly open mind about chemicals. There are some herbicides that have developed over the last several decades, you know, since Rachel Carson wrote Silent Spring, that have very specific targets and very low toxicity to the applicator and to insects and other animals. I'm not a no chemical kind of guy, but there are some things like the neonicotinoids that are extraordinarily harmful to the environment, and in my opinion, should not be allowed. I mean, these chemicals should be banned because you can buy these at like a big box store. I'm not gonna name any particular names, but these big truckloads full of plants that come from nurseries where they use the neonicotinoids out of on every single plant just to avoid any insects coming onto them. And they will kill aphids and butterflies without regard. They kill any kind of insects, and they will last up to 1.5 years. So they persist for a really long time. You may be buying some plant like a buddleia and you think that's going to be good for my butterflies, but if there's neonicotinoids, you're creating a death trap for pollinators. So these are extremely bad and should be avoided. I mentioned before the bee houses. Well, there's a little bit of care and etiquette involved in this whole bee house thing. And it's like bird feeders. People will put out bird feeders, but if you're not cleaning a bird feeder periodically, we might actually be creating more harm than good. You know, with avian flu right now, it's particularly concerning that birds might be getting sick by coming to your feeder with congregating with other birds. And if we don't clean the feeder, we could be spreading pathogens from one bird to another. And the same is true with the bee houses. They should be cleaned, and these tubes should be replaced every other year. And so a good strategy is to have 2 bee houses. One has the overwintering insects in them, which will emerge in the spring, and one has you can trade out one for the other after all the tubes are empty and the bees have emerged. And this way, they need to be cleaned because they can get parasites in them. They can get mold and fungus in them, which is bad for the insects. So just putting up the bee house itself isn't really enough. It needs to be cleaned periodically. That's why I think the tubes that you can replace are better than the things where you have holes drilled in wood. Unless you just drill new holes and replace that wood periodically, those types are hard to clean. But I wrote an article about this in the Colorado Gardener, and we got some advice on how to maintain bee houses, and that you can find that article at the Colorado Gardener online, or I also have a blog on our website, suburbitat.org, where the article is there as well. And so there's details about how to maintain these bee houses. Create intense concentration of flowers, the larger, the better. That's within the scale that's possible in our yard and within the scale of our means. This garden here is at Chipungu Sculpture Park, a 28-acre park that High Plains Environmental Center manages. And last year, we put, I think, 1,400 plants from our nursery. And this is a very low-lying and wet area. So we planted plants that are native to the tall grass prairie. We do have tall grass prairie in Colorado in low-lying areas adjacent to wetlands. And so a lot of these species can be found there. And we wanted to do a garden that was entirely focused on the tall grass prairie because of the moisture of the site conditions. But it's intensely planted, and we like to let plants go to seed and let those seedlings fill in and have a little bit of like a free hand with how the plants fill in and move around and get like this really, really dense, really full meadow sort of look. And that's what we've created here. It's kind of like a billboard on the highway for pollinators. If you had a tiny little sign, a driver might not notice it. And we have a huge billboard, it's more obvious. And the same thing is true here for insects. If you have a large patch of flowers, it will just get more attention from insect visitors. And why not take up the entire lawn and replace it with interesting, colorful plants like this? Providing the bare ground is important because, again, a lot of bees will nest in the ground. The queen bumblebees overwinter in the ground, just a few inches below ground. That's how they survive. And it's one of the reasons we recommend to people, don't go stomping around in your garden early in the spring. You could very easily crush where there are hibernating and nesting bees. And having rock mulch, having bark mulch, and certainly weed barrier. I think there's virtually no use for weed barrier. Any biodiversity or any ecological function that your garden could have is almost totally negated by the weed barrier, because everything that lives below ground and needs to get above ground, it just creates a dead zone where none of that is possible. And so you're dramatically reducing the ecological function of your garden if you use weed barrier. So try to provide some bare open ground. And be a lazy gardener. These are the reasons for not cutting your garden back in the fall. First of all, look at it. It's cool. And it's like, this is one of the things that is so great about gardening in Colorado. In Europe or in the East Coast of the United States, winter is wet and dreary, and the plants rot and just turn into this black rotting mess of vegetation. Here, everything just freeze dries right in place. And you see the little snow caps on the flowers of summer, which is an interesting textured look. I think that this is one of the most interesting things about gardening in this part of the world. Certainly, I would never cut grasses back until the spring, because that's the best time of the year for grasses. They hold their dried colors and they hold their form very well. Here I can see the butterfly milkweed pods dried in place. So it creates a lot of winter interest to leave all this in place. It also protects the plants from the desiccation. Denver is said to have more freeze-thaw cycles than any other city in the United States. So here on the Front Range, it's freezing and thawing all the time. That is hard on the plants, and just that little bit of foliage will shade the ground, keep the ground from thawing out too quickly, and will protect the plants and helps them get through the winter. It also provides cover for insects and wildlife in wintertime. So again, there's insects under there, and it's the vegetation is a blanket for them. You also will see hungry birds in wintertime picking at these dried flowers, getting the last few seeds off of our echinaceas and black-eyed Susans and so on. So it does provide some forage for birds in wintertime. And perhaps most importantly, there are pollinators in those plants. So a lot of these plants have hollow tubes that there are eggs or dormant insects inside. If we're cutting that off and we're removing it too early, we are possibly removing the insects from our garden. So we're throwing pollinators away. And obviously that's antithetical to our goals. People ask, how early is too early? And that is a really good question. I think a good rule of thumb is when you start seeing insects being active in the environment, you know they're emerging from dormancy, but that can often be like in May. And so I would go slow, and you might consider some zones in your garden. Like the front yard, you maybe want to clean up and have that be looking presentable earlier in the year. So, you might get started there in late March or early April and slowly kind of remove that cover. But if you could leave some portions of your garden, you're hedging your bets a little bit, and you're letting some of these dormant pollinators and so on make it through the winter. So consider some zones that are more wildlife friendly, where you really don't get into messing with that at all until May. And lights out. The porch lights and outdoor lighting do a number of things that are bad. For one thing, we don't see stars. If you go out we are fortunate if you live in Colorado or New Mexico or Wyoming, and you go out in the country at night, you can see that glittering vault of stars at night, where most people in the world do not see that anymore. And as human beings, this was part of our life for millennia. And now people hardly see the stars. So that's important. But also, a lot of lights at night are disorienting for migrating birds. It can be extremely disorienting to the life cycle of insects. And consider having a motion activated light. So if someone comes up on your porch, the light goes on, but then it goes off again. And that will give you back your darkness, because darkness and silence are two things that are really endangered in our world. There's always noise, there's always light. And so that will have some darkness back in your yard, and also will greatly benefit pollinators in your immediate vicinity. And avoid pruning to death. Here's an example of red twig dogwood. And this is a plant that typically grows by the river's edge. It's a riparian plant, and it likes to have 1 foot in the water. And if we plant it in front of a hot building and we prune the life out of it, we could be really damaging the plant. The one on the right here is a plant that's like sheared within an inch of its life. It's really losing its natural form and really struggling there. I think this plant might have even had mites or something on it, because it was just in a hot location, not the right plant. If you want something that's going to stay 3 feet high, then plant Potentilla or something that's just going to be that size. But we don't need to shear everything into like a hedge or a ball, and let plants have their form, and particularly taller shrubs, because birds need to get up off or some birds will nest on the ground, but a lot of bird species need to be up off the ground, be safe from predators. And our landscape can provide this kind of breeding area. It's one of the classic definitions of habitat is food, water, shelter, and space, or space to rear their young. And taller shrubs and trees provide that. So let's not prune things to death. There's an interesting term that I learned from Paul Opler, and that is trap lining. And you will see this occur once you plant native plants. I see this on my patio at home, and my wife and I take great delight in being out, maybe drinking coffee in the morning, sitting out on our patio, and we see hummingbirds will come by. They'll visit our echinaceas, they'll visit our salvias, and then they'll take off and they go to their neighbors who have plants that are tube-shaped flowers that they feed on. Later on, they'll come through again. They'll visit that over and over and over and just get the nectar as it's being produced by the flowers. And the 100 species of bees that we see in our garden, they come here because of the native plants, and they either live here or they visit here over and over and over again. And that trap lining, kind of like, the term comes from if somebody has a trap line in, the Yukon or Northwest Territories of Canada or something, and they go to that trap line and check it every day. That's the kind of thing that pollinators are doing. So So your address will come up on the pollinator map, and they will come back again and again and again once they become used to your offerings from your garden. I want to talk about this insect because I've seen, like, my friends on Facebook are like, wasps are nice, don't, you know, they're pollinators too. And yeah, there are native wasps, they're part of the ecosystem. This insect is a pest, and mostly because they are devastating our butterfly population. They've only been in Colorado, I don't think more than a decade, and they are becoming really prolific. You see them everywhere, and they visit the same flowers to get nectar that that many of our other pollinators do, but they will lay eggs in caterpillars, and so that's why they're devastating all the Lepidoptera, the butterflies, and moths. And this is an insect that I believe should not be encouraged or should be destroyed. And the easiest way to do that is to just remove these. They make this papery chambered structure and lay eggs in it. And if you have a garden shed or the eaves of your house or any place like that, if you see these being made, remove those, because they will really raise havoc on. There's no point in creating a garden that will attract butterflies and having them be lured to their death. So I think if we want to successfully preserve butterflies in Colorado, we also need to manage the species. They will also be abundantly caught in those wasp traps that you see like in hardware stores. And if you put it out early in the spring, you can get the queens of this species. Phenology is basically just the idea of when things bloom. And this is very important when we're thinking about creating a pollinator garden, because I can't only eat on Monday or only eat in April. I eat every day, and so do pollinators. And so if you want to have pollinators visiting your landscape continually, then you need to have offerings throughout the year. And that's just good garden design. I have noticed that most people have gardens that abundantly bloom in the spring, because that's when people go to garden stores and you see something in bloom and it's like, oh, I want that candy top. You bring it home and plant it. But a wise gardener, an informed gardener, knows about things that bloom in July, August, September, and October, and seeks those plants out and plants those plants. They may not be in bloom when you buy them, and really it's not a good idea to buy plants that are flowering anyway. But this is to plan what plants will be blooming throughout the season. And in order to help with that, the Denver Botanic Gardens, CSU Extension, Front Range Wildlands, High Plains Environmental Center, Colorado Native Plant Society, and the Butterfly Pavilion created this 2-page handout. And I think that we can email a copy of this to everybody in this class. It's just 2 pages. And the rest of my slides just sort of unpack this idea of like early season, middle season, and late season. But these are not by any means the only plants, but really just giving an idea of how to plan a season-long garden that will benefit pollinators and also be an attractive, interesting garden in throughout the season. And we also created these 5-region booklets, and that the one for the Front Range can be accessed on our website, suburbitat.org, on our native plant page. So we have a native plant nursery, and we have the booklet there. You can just download the booklet. And I'm assuming most people are in the Front Range. But this has a little schematic plan for a garden you could create, and just kind of talks about how to create a native plant garden. So these are the plants of the early season, that's the spring season. And I'm going to go through this a little bit quickly because it's 10:36 and want to make sure we have time for a few questions. So Allium cernulum, the nodding onion, this has pale pink umbels. It's 6 to 12 inches tall, grows in open woodlands and sunny, dry locations up to 11,000 feet in elevation. That is something that people ask us fairly often. If you live in a high elevation, what grows up there? So we have tried to indicate that in the booklets as well as this pollinator sheet. And it's pollinated by bees and insects, which attracts butterflies, including the hair streak butterfly, as well as hummingbirds. The sulfur buckwheat, Eriogonum umbelatum, and there's actually also Eriogonum arcuatum, which we grow here in our nursery. These are 6 to 12 inches tall. They grow in sunny, dry, well-drained locations up to 10,500 feet. Flower heads and leaves turn reddish later in the season. There are places at Rocky Mountain National Park or at Shambhala Mountain Center, I've seen like large, extensive patches of these. And they are particularly attractive to what are called the blue butterflies, of which there are several species in Colorado. Those blue butterflies exclusively feed on the genus Eriogonum. So that is the notion of a lid galactic. Prairie smoke, or Geum triflorum, has nodding rose pink blossoms followed by long feathery seed pods, 6 to 12 inches tall, grows in sun and part shade, moist to part dry, up to 10,000 feet in elevation. I've also seen large expanses of these in wet meadows. I photographed a bunch of them at the Steamboat Lake State Park. Wildlife value is nectar and pollen for generalist pollinators. So the idea of generalists, often daisy-shaped flowers that are flat and easy to access, will attract a lot of different species. And generalists are the opposite of a lid galactic. They'll go to anything they can get nectar from. And so that is what is drawn to these. The wallflower, Erysimum capitatum, 6 to 24 inches tall. It's biennial or short-lived perennial, grows in sunny, dry locations up to 8,000 feet, adapted to pollination by longer-tongued insects such as bees, due to the tube formed by the separate petals. Firecracker penstemon, this is the one that we list in our sheet, but I'm going to tell you that Penstemon barbatus, don't remember the common name for that. It looks just like this, but it will bloom all summer long. The firecracker penstemon only blooms for a week or two in June, but penstemon barbatus is the one that I would recommend because you just get so much mileage out of that. Bright red blossoms on spikes 1 to 2.5 feet tall, sunny, dry, well-drained locations. Bees love all penstemons. Also, they attract hummingbirds and are said to be rabbit resistant. The blue mist penstemon, Penstemon virens, has small blue-violet spikes up to a foot tall in late spring, grows in dry, well-drained locations in sun, apart shade up to 10,000 feet, attracts birds, butterflies, bees, and it's deer resistant. Ask flower, you often see the Pulsatilla vulgaris, but this is the Pulsatilla. This actually, the genus name has changed on this, so it's now called an anemone. But 6 to 12 inches tall, part sun, moist to dry locations up to 9,000 feet. Cup-shaped lavender blossoms followed by feathery seed heads, pollinated by flies, butterflies, wasps, bees, and other native bumblebees and other native bees. I do recall this from Shambhala Mountain Center as being one of the first things that blooms in the spring. And so it's good for those early pollinators. Golden banner. I do want to mention that this plant is toxic if you have small children or pets that chew on stuff in your yard. Be advised that this is a toxic plant, but you know, a lot of plants in household plants are toxic, and quite a few native plants, particularly of this Fabaceae family, are toxic. Grows 1 to 2 feet tall, part sun, moist to dry locations, but I would say more moist. And when you find it growing in the wild, it tends to be in wet meadows, up to 9,500 feet in elevation. It can spread aggressively, which some people like and some people don't like. I personally tend to like plants that will spread and fill in, but if you want a plant to stay in place, you might not want this one. The wildlife value is nectar and pollen for bees and butterflies. The mid-season plants, I'll just go through the slides. Pearl everlasting, Anophelis margaritacea. It's silvery foliage, clusters of straw white flowers. So these, as an everlasting, you can cut this flower and it'll remain like this, used for dry flower arrangements. 1 to 2 feet tall, in sunny, moist, or dry sites, up to 10,000 feet in elevation, utilized by bees and butterflies. It's the larval host for skippers and the American painted lady butterfly. And the American painted lady butterfly we tend to see some years in quite large numbers here in the fall. Milkweed species, Asclepias, 3 to 4 feet tall. This is a back of the border sort of plant. This particular one is a bit rangy. I feel that the Asclepias incarnata, the rose milkweed or swamp milkweed, is a better plant for gardens. This milkweeds will grow up to 8,000 feet in elevation. And of course, they self-seed by creating that little puff that will carry the seeds around to different locations. Provides nectar and pollen for many pollinators, host plants for the monarch and the monarch butterfly larva. I quite often see this, the two-tailed swallowtail on it, more than I see monarchs. The harebell, the Campanula rotundifolia, this plant is circumpolar and grows all the way around the world at a certain elevation. The nodding bell shaped flowers, 6 to 12 inches tall, in moist, dry, sun to shade up to 13,000 feet in elevation, pollinated by bees, bumblebees, butterflies, and attracts hummingbirds. The Erigeron speciosus, this is a plant that also will spread considerably. Again, some people like that, some people don't. It's a daisy type flower, lavender with yellow centers, 1 to 2 feet tall, sun to part shade, moist to dry up to 9,500 feet in elevation. This is a plant for generalist pollinators. Again, that open daisy type flower makes it easy to access. Blanket flower, Gaillardia aristata. Even though this is a mid-season plant, it is indeterminate. So there's nothing in this plant that tells it to stop blooming, and it will go until the end of the season. So I would actually say this is a mid to late season plant. The one that's actually native to this area is solid yellow, whereas you see the blanket flower that's orange stripes, orange and yellow stripes. That is a native plant, but it's not locally native. This is 1 to 2 feet tall, up to 9,000 feet, grows in dry, well-drained, sunny locations. Most of the commercial varieties are non-native hybrids. It's long blooming. Wildlife value is nectar and pollen for bees and butterflies, resistant to deer because it's very scratchy. If you touch this plant, and collects the seeds from it, it actually can aggravate your skin because it's scratchy to the touch. Bee balm, Bernarda pistiolosa, is 2 to 3 feet tall, sun to park shade, moist or dry up to 9,000 feet in elevation. Nectar and pollen for bumblebees, butterflies, and hummingbirds. This is one of those plants that the pollinator needs to have a long tongue to access the nectar. Rocky Mountain penstemon, this is very, very easy to grow. If you're not used to growing native plants, plant this. You will definitely feel like a gardening hero because it will grow prolifically. 1 to 2 feet tall spikes and dry to well-drained, sunny to part shade up to 10,000 feet in elevation. Wildlife value is nectar and pollen for bumblebees, but again, the bumblebees and penstemons have close ties. Butterflies and hummingbirds. And this bee is the Bomba nevadensis. Black-eyed Susan, Rudbeckia hirta, is golden yellow with brown centers, biennial. It's a short-lived perennial, reseeds readily, grows in dry mountain meadows up to 9,000 feet in elevation, moist to dry locations, provides nectar and pollen for bees, butterflies, and seeds for birds. And in the late season, we have Rocky Mountain bee plant. This plant can be grown very easily from seed. And basically, you just throw the seed out on any disturbed ground in the fall. And if you have larkspur, a European annual, in your garden, it grows like that. It will just like around this time of the year, when it gets a little bit warm, just one day you'll go out and you'll just see it will have popped up all over the place. This is a great, particularly if you're creating a new garden and you want to fill up the space, these kind of annuals are a great way to fill up that space while the perennials are getting established in their second and third year. And it'll provide immediate benefit to hummingbirds, butterflies, bees. Really a cool, easy to grow annual. 1 to 3 feet tall, large pink lavender flowers, reseeds readily, grows in sun to park shade and well-drained soil up to 7,500 feet. And you just grow by scattering the seeds in the fall. Sunflowers, all sunflower species are native and are beneficial to pollinators, including butterflies, moths, bees, and flies. Depending on the species, it can grow anywhere from 2 to 5 feet tall. Not all sunflowers are annuals. There's several perennial ones, including the little sunflower and the Maximilian sunflower. They grow in sunny, dry, well-drained locations. And you need to give these plants a lot of room for an informal type meadow. I've seen really successful plantings of the sunflower and the Rocky Mountain bee plant. This is like the easy, cheap way to get immediate pollinator benefit, then be very showy late in the summer. And then you'll see the goldfinches come and really feeding on those seeds. Rocky Mountain gay feather actually changed the name from the one that's on the list, which is Liatris punctata, which is also native, blooms in August and September. Definitely a good plant. But this plant, the Liatris ligulostylus, is a butterfly magnet. It's crazy how much this is attractive for butterflies. Spikes of fringed rose purple flowers up to 40 inches tall. This is a super great plant. It's not easy to find. We have them in our nursery, but they're this is a plant select plant, but they're not easy to find. But super pollinator attractive. The tansy aster, Macaranthia biglobii. I have to say about this plant, if you do not like plants that go to seed, spread around, fill in here and there, and it's a little pejorative, but I would say it's kind of weedy. But this plant attracted more pollinators than any other plant that that Paul Poplar looked at in our garden. And I think this one and the sunflowers have extra floral nectaries, which means that they have nectar sources other than on the flower. So it means that they will get just all kinds of pollinators will be having a field day with this plant. Has lavender stems up to 6 to 30 inches tall, depending on the moisture availability. Goes up to 8,000 feet. Goldenrods, all goldenrods are great pollinator and wildlife plants. Depending on the species and the moisture, they grow 1 to 4 feet tall. Bloom in late summer, attract a wide range of insects that benefit from its nectar and pollen. And I wanted to throw in some shrubs and trees. And remember before I was saying that in the foot of cottonwood trees, you often see chokecherries, golden currant, snowberry, woods rose, all grow in this extended community. And particularly in open spaces, it's really advisable to plant these plants and replicate this structure. Interestingly, a study has been done that says that the cottonwoods are actually pulling up deeper moisture and not competing with the shrubs, but actually bringing that moisture to the shrubs. So they're benefiting each other. One of the reasons they might grow together like this is the birds sit in the trees, they eat fruits, and their droppings have seeds, and that causes these plants to grow at the foot of the cottonwood trees. But you'll notice this in springtime and fall. Drive around in kind of in the countryside, look at cottonwood trees, and you'll see these shrubs blooming prolifically in April or turning bright colors in the fall. Rabbit brush. Some people consider this plant weedy. I think it's a really great native shrub that's very showy and will attract a lot of butterflies, particularly the American painted lady butterfly, which seems to follow this plant as it blooms on its migration. So it has bright yellow flowers, up to 6 feet tall. This can easily be controlled by cutting this plant right to the ground in the spring. You can just like chop it right down, and it'll grow back again. This grows up to 8,000 feet in elevation. Prunus americana is interesting. It just says hate, like hate ashbury, where it should say height. The height is 12 feet. Spreading shrub that often forming extensive colonies. So the interesting thing about this is it does not grow with other shrubs, but it grows by itself. And there's a theory that this plant was selected by bees to bloom early and bloom in open sunlight. And that seems to be what the pollinators favor. This is an important plant because it makes this Welch's grape juice smell very, very strong in April. Flowers before it leaves out. It's very important for those pollinators that will forage in the sunlight. And later on, it will, after the flowers go by, the leaves come out. But for some reason, this plant is almost always found growing in sometimes in an extensive colony, but only with itself. Chokecherry is a great wildlife plant, provides the fruit for birds and animals. It's a host plant for caterpillars, the western tiger swallowtail, two-tailed swallowtail. So an important host plant for butterflies. This plant can grow quite extensively, and so you got to really commit to it. You will find it if you plant it, it's going to pop up in different places of your yard. And again, people are either going to like that it's kind of naturalizing, or not like it. So be advised there. Golden currant. I think if I was going to recommend one native shrub, I would recommend this because it grows like ornamental shrubs that are popular, and it does what we expect a shrub to do, in that it has fragrant, beautiful flowers in the spring. It produces fruit that birds like, and human beings can eat it as well. And it will have beautiful fall color. It's a great plant. It's a host for the zephyr angelwing butterfly, and birds like the seeds. So grow up to 10,000 feet in elevation. And it will top out at about 6 feet. You can really grow this without pruning at all in your typical landscape. Boulder raspberry, again, this is a rosaceae, lots and lots of stamens with 5 petals. This is a plant that in the wild you will not notice until it blooms, and then it's kind of hard to miss this huge white flower. It's pollinated by bees, has great fruit for wildlife. Will grow up to 9,000 feet in elevation. Rosa woodsii is not a big showy rose like those ones that you buy in the supermarket or garden store in the summertime or spring. However, you probably have noticed that those roses have had the scent breeded out of them. This has the rose like the fragrance like your grandmother's rose garden. Really strong rose fragrance, 5 petals, only blooms one time, but then it forms large rose hips that can feed birds in wintertime. So grow up to 10,500 feet in elevation. This rose will spread. So again, you don't want to, in the thicket of this, this probably isn't the plant for you. This is what I think our suburban landscapes should look like. Forget the turf grass. This is beautiful. And there's so much going on in here. This was planted by our neighbor in our neighborhood. I think it's just such a good example of what this kind of meadow landscape looks like. They water this very, very little. They cut it back once in the springtime and just do a little bit of weeding here and there. There's so many plants there. There's not really space for weeds. And what I see there is the Mexican hats or prairie coneflower, the yellow, the butterfly milkweed. That deep magenta is the desert 4 o'clock, Mirabilis multiflora, and then Echinacea pallida, probably. Echinacea pallida, maybe Tennesseeansis, which isn't actually native to Colorado. And sagebrush and native shrubs. Just such a good, also there's the purple prairie clover, another really, really great native flower. So such a good example of what's possible. It's beautiful, it's easy to maintain, and it provides tremendous benefit in the places that we live. High Plains Environmental Center has a lot of plants that we grow, 120 species. Some of them are quite rare and difficult to find. This is Stephen. He's a propagation wizard. He's on our staff here, our nursery manager, really growing some really exciting, cool things out there. Hard to find, like the Castanea, all kinds of cool stuff. Our plant sale launches on March 31st. And so do check that out. We will have plants available till the end of September. And I wrote a book called Suburbitat, A Guide to Restoring Nature Where We Live, Work, and Play. You can scan this QR code, which will take you to the book. At this point, it's only an electronic book, but you can read it on your phone, iPad, your laptop, or anything. And there's a lot of photographs. There's some history of the area, how High Plains Environmental Center came to be, what our mission is, what we are trying to build here. And really changing the world to being more supportive of biodiversity. There's specific nuts and bolts advice on how to do that in the book, as well as some essays about creating a culture of environmental stewardship. Thanks, everybody. I've gone right up to the end of our time. But if you want to stay tuned, I will read some questions here. I need to adjust my audio. Christine said, I'm glad you're opposed to neonics. Wish you had a clear stance on pesticides in general. I'm quite clear on that. I am not opposed to all pesticides, and that's a fact. I